If you only looked at these two diamonds, would you be able to tell which one was worth over $20,000 and which one was only about $7,000? They look almost identical, right? And believe me, both are real diamonds. One of these diamonds was created in a lab. That's called a lab-grown diamond. So how did humans create it? Let's find out in today's video. The most controversial question regarding lab-grown diamonds is, are they truly considered real diamonds? And the answer is yes. Scientifically, lab-grown diamonds are essentially real diamonds. They are both made from crystallized pure carbon and have almost the same atomic structure, hardness, light reflectivity, and thermal conductivity as natural diamonds. That's why, to the naked eye, most people can barely distinguish between the two. If it's almost impossible to tell them apart with the naked eye, would you choose a natural diamond or a lab-grown diamond? Leave your opinion in the comments below. Just a few years ago, lab-grown diamonds were still considered a high-tech luxury product with a fairly expensive price tag. But today, this market is changing extremely quickly. According to multiple industry reports, the price of lab-grown diamonds has dropped sharply in recent years, with some categories falling by more than 70% in just a few years. What's especially notable is that a lab-grown diamond once sold for around 50% of the price of a natural diamond of the same size and quality back in 2018. But only a few years later, that number had fallen to around 35%. And the reason behind this decline is actually quite simple. Lab-grown diamonds can be mass-produced. As the technology continues to improve and more factories enter production, supply has started increasing very rapidly. That has caused lab-grown diamond prices to fall significantly over time, completely unlike natural diamonds, whose value depends heavily on rarity and tightly controlled supply. Interestingly, the vast majority of lab-grown diamonds in the world are not actually created for jewelry. They are produced for industrial purposes. Diamonds possess an extremely important property. They are one of the hardest materials ever known to mankind. Therefore, lab-grown diamonds are now used in many high-tech fields, such as oil and gas drill bits, concrete cutting blades, metal polishing, and ultra-precision machining equipment. In addition, some AI chips and high-performance electronic components are currently being researched using lab-grown diamonds due to their extremely strong thermal conductivity. Beyond industry and jewelry, the technology for creating synthetic diamonds is now being applied to a very humane purpose, transforming carbon from cremated remains into commemorative diamonds. Several pioneering companies, such as Algordanza in Switzerland, have developed a process of extracting carbon from the cremated remains of the deceased, then using HPHT technology to grow it into a diamond in the laboratory. After a few weeks, that carbon gradually crystallizes into a real diamond with a structure almost indistinguishable from a natural diamond. Some even have a distinctive blue color due to the boron content remaining in the human body. These companies also allow customers to choose the color, size, cut, or engrave names and dates on the stone as a permanent keepsake. Lab-grown diamonds are often marketed as a greener and more environmentally friendly option than naturally mined diamonds. But the reality is much more complex. To create a lab-grown diamond, HPHT or CVD systems must operate at extremely high temperatures and pressures for days, even weeks, continuously. This means these factories consume enormous amounts of electricity. And the problem is, if that electricity comes from coal or fossil fuels, the carbon emissions can still be very high. Some studies even suggest that in certain cases, The emissions from lab-grown diamonds are not significantly different from those from traditionally mined diamonds. And despite the many ongoing debates surrounding the value and environmental impact of lab-grown diamonds, more and more major jewelry brands have started entering this market. Even De Beers, a company that spent years protecting the value of natural diamonds, has entered the lab-grown diamond market with its own brand. The reason is fairly simple. Demand is growing extremely fast, especially among younger consumers. For many people, owning a diamond that looks almost identical to a natural one but costs 70 to 90% less is an incredibly attractive option. Not only that, lab-grown diamonds also allow brands to reach entirely new customer segments. Instead of spending tens of thousands of dollars on a large natural diamond, buyers can now own stones that are bigger, more flawless, and significantly more affordable. And that shows a rather clear fact. Whether you like it or not, lab-grown diamonds are now gradually becoming a real part of the global diamond industry. So how do humans actually create diamonds? Currently, lab-grown diamonds are created using two main technologies, HPHT and CVD. Let's explore how lab-grown diamonds are created using HPHT technology. This process begins with selecting a source of very high-purity carbon, most commonly graphite. The graphite is then ground into a fine powder with uniform particle size, as the stability of these carbon particles directly affects the subsequent crystallization process. Simultaneously, catalytic metals such as iron, nickel, or cobalt are prepared separately in powder or small metal pellet form for use in the diamond crystallization stage. After the materials are prepared, technicians assemble them into a multi-layered material with a pre-calculated structure. Carbon powder, a metal catalyst, and a tiny diamond seed are placed in a specific order. This seed is essentially a microscopic piece of diamond, acting as a starting point for carbon atoms to gradually attach to and grow into larger crystals over time. The entire assembly is then encased in a material capable of withstanding extremely high temperatures and pressures, usually a special alloy or specialized engineering ceramic. When completed, it looks like a small, relatively simple black block, but inside it contains all the necessary conditions. The material is then fed into a specialized pressing system capable of simulating the extreme environment deep underground. Inside the HPHT chamber, pressure increases to tens of thousands of atmospheres, combined with temperatures exceeding 2,000 degrees Fahrenheit. Under these conditions, graphite begins to gradually melt within the catalytic metal layer before the carbon atoms rearrange and crystallize around the diamond seed. The crystal will not form immediately, but will grow slowly over hours or even days. After the pressing process is complete, the system is cooled and the pressure is gradually reduced. When the pressing chamber is opened, technicians remove the material inside to reveal the diamond that has grown around the original seed. Next, each crystal is examined under a microscope and specialized optical equipment to assess its color, clarity, and internal structure. Those that meet the standards are then sorted by size and quality before being sent to various other fields. That's HPHT technology. So what's different about CVD technology? Watch the rest of the video to find out. In CVD technology, the diamond seed is arguably the most important component. These are extremely thin slices of diamond, typically only a few hundredths of an inch thick. The surface of the seed must be polished to a microscopic level. These seeds are then placed on a support system inside a vacuum chamber, and fixed with extreme precision in terms of position and crystal orientation before the diamond growth process begins. Once the seed diamond is secured inside the reaction chamber, the system begins to introduce the gas mixture into a vacuum. The two most important gases at this stage are hydrogen and methane. In this state, carbon does not exist in solid form, but is held within the gaseous environment inside the reaction chamber. Once conditions are stable, the system activates the plasma using microwaves or high voltage. At this point, a glowing plasma region with extremely high temperatures appears inside the chamber. However, the amount of heat directly affecting the seed diamond is carefully controlled to avoid damaging the developing crystal structure. When the plasma begins to create free carbon atoms, they move inside the reaction chamber and gradually adhere to the surface of the diamond seed. Each new crystal layer is only a few carbon atoms thick, and this controlled growth rate is what gives CVD diamonds their high purity and uniformity. The key difference is, while HPHT technology uses extremely high pressure to force carbon to crystallize, CVD creates diamonds by slowly growing crystals on the surface of the seed. Tiny carbon layers continuously stack on top of each other until a complete diamond is formed. Lab-grown diamonds may still be controversial. To some, they're just lab-grown stones. But to many others, they're fundamentally changing how the world views the value of diamonds. And perhaps most interestingly, for the first time in history, humans have learned how to create something almost identical to nature's product, right inside a factory. If you enjoyed this video, don't forget to leave a like, subscribe, and turn on notifications to continue discovering fascinating stories behind technology, materials, and the familiar things around us.